Hi, so today I'm going to talk about something that basically I'm asked about all the time. Whenever we're out at events, whether we're with the dragons, with the Batmobile, with the robots, whatever, I'm always asked about sound. How do we get sounds into our props, into our models? How do we do it? What do we use? And do you know what? Literally, I'm asked it all the time. So what I thought, I'm going to do a video about how we do it, share some of the secrets and give you some ideas on cost, solutions or cheap solutions to do what you need to do. There is a golden rule though, and it's the golden rule I always kind of work by. Keep it simple. Design something for what it is that you need. There's no point going out buying the latest gadget that can do everything if you're not actually going to use any of it, or it's so complicated that you don't know how to do the coding or the programming or things like that. Keep it simple. Keep it simple. So the first thing you need to do is plan out your sound architecture. Ask yourself, what is it that I actually want to do? What sound do I want to trigger? There's no point saying, right, I'm going to trigger 50 sounds when you only need 2. Really, you need to think it through. Now, the simplest form of sound that you can use on any build or any model is a phone. Simply, and lots of people have got old mobile phones, simply put some sounds onto your phone, connect your phone via Bluetooth to a Bluetooth speaker. And they come in loads of different sizes. You've got the little ones like this that will fit inside smaller models. I quite like the JBL speakers, the ones like this. I think they're brilliant, and again they come in all different sizes. You've got these sizes, and you've got the bigger ones. So there's loads that you can kind of do. And I'll tell you what, these things pack a punch. They're small, but they are incredibly powerful units. Plus they've got their own self-contained batteries, meaning they can run up to 24 hours, some of them, and it doesn't impact then on your power system within your model. One of the big things about sound that I've learned over the years, if you want big sound, sometimes you need to use big speakers, big amplifiers. In the old days, I actually used to use these. So basically, units like from cars that you get, big amplifiers from cars. In fact, one of our Daleks has a very similar system in. So 1,000-watt amplifier, huge big subs, giving all that bass. Sounds amazing. Sounds incredible. But there's a cost, and that cost is power. The louder you turn your amplifier, the more power that you use. And that's where these kind of come into their own, in that they're self-contained and, they're powerful, but they use their own battery systems. Anyway, simplest form, phone, Bluetooth speaker. It works, it's very efficient. You can have unlimited number of sounds. It's great. So what's the catch? The catch is delay, lag. Newer Bluetooth systems, I don't know what we're on now, Bluetooth 5 or whatever, or 5.1, I'm not sure, are better than they used to be, but there is still a noticeable delay. You press a button on here, or you trigger a sound on here, and there is a noticeable delay by the time it gets to the speaker. If that's not a problem and you don't care, and you just think, well, I just want a sound, it doesn't matter whether it's delayed, you can't do any better than that. It's the cheapest, simplest solution that you can use. Remember, on anything that you use, whether it's a soundboard or a complicated system, you are going to need an amplifier and a speaker. So whether it is a little cube like that, which is, a lot of these things you can plug in external units, or whether it's a bigger, you're going to need to buy that anyway, regardless. So that's the Bluetooth system. That's the simplest system. What I tend to use a lot are soundboards, and here there's a little soundboard there, little little one, costs about £7, that one, and there's this one here which costs about £10. This one's actually got an amplifier built in, so you can connect. I'll show you. I'll connect it up. I've got a wire here plugging into the back of the little JBL speaker, and that will plug directly into the kind of, if you like, it looks like a headphone socket on there. And that will now provide amplification. These units, though, can also be used with an external speaker. That speaker can be wired directly to it because it has an amplifier built in. It's not very powerful, but for a smaller model, that might be more than enough. And you literally just connect your speaker, wire your speaker up to the board, and then put power into your board, and then away you go. It's that simple. Word of advice, speakers are strange things. Now, mount that straight into your model, it's going to sound rubbish. Even if you mounted that, and you can see the difference, into your model, it would still sound stupid. Speakers are all about moving air, pressure waves. And to increase the efficiency of this speaker, you need to put it into an enclosure. 40% of the power from the speaker goes backwards. Put it in the air, this cone isn't loaded up, so it will sound weak and feeble and no bass. Put it into even a rudimentary enclosure, made of wood, plastic, whatever you want, it will sound 10 times better. Put a little hole at the front, let the air out from behind, it's called a bass port, makes the sound even better. So put your speaker into an enclosure. Find a way in your model to build a box around your speaker, and it will sound really, really good. The people that make these things, there's clever electronics in here that make these sound good. And I'm not going to go into what all that is because that's a different video. But you have either solution, you know, speaker directly in, won't be as loud as an external amplifier, but you may not want loud. But what you do need, though, is a soundboard. Now, these soundboard, as I said, is very, very simple. You can plug a speaker directly in, plug an amplifier directly in. The sound comes from a micro SD card, which that's where all your sounds are stored. So get them off your computer, put them onto the little card. You've got to name them appropriately, and the manual that comes with the sound card tells you how to name them. And once they're on there, we then can turn our sounds on and off. And the way we do that is all these wires. Now, this just provides power, because all of these boards have still got to be powered, and they can be powered from 5 volts through to 30 volts. You know, they vary. But this is called a trigger board, and this is the kind of board you need because it means that we can trigger a sound. Now, here, this black wire here is the earth wire, and there's this green one. Where is it? There we go. That's channel 1. There's 8 channels on here, and each channel, or each sound, can store, well, I've got about 30 minutes on each one at the moment, so it's a phenomenal amount of time. But it's simple. When you touch those two together, it makes a sound. If I touch that's number 1, it plays sound number 1. Touch it number 2, plays sound number 2, and so forth, and so on. I'll give you a quick demo. So let's power up the board. This little battery there to power it up. Going to use the JBL speaker. Let's just plug it in. So let's power the board up. I'm running 12 volts into the board. See, look, green light comes on. And all I've got to do is take the earth wire and touch it to that. And there's like a droid sound I've got pre-loaded. Earth wire touched to that. And I think I've got another one on there. 2 sounds. You just touch the wires. Switch. Off. On. Off. On. Very, very simple. So, soundboard. That's the bit you need. This little board, as I said, cost about £10. Very, very simple. Very, very easy to use. So, how do we connect the wires? We can't just, this is in our model, remember. We can't kind of walk along touching wires together. That's kind of not going to work. It's really, really simple. We use switches. Now, a switch, it doesn't, you know, that's a little push button switch. That's a little toggle on and off switch. This is a clever little weighted switch. So when you move the weight around, it opens and closes the switch. You can get these things everywhere. They come in, there's thousands of different kind of switches you can buy. I use these ones a lot. No idea what they're called. But basically, they've got little levers on them and it's a little switch. So when you push it down, it connects these two together. So our sound would be connected to those two there. So instead of touching the wires together, I just go like that, open and close the switch, and it turns the sound on. So if I wanted 8 sounds, I need to use 8 switches. Now, you might think, well, yeah, but how do you do it? Well, think about it. On my robots, let's say the droids. They have a utility arm. That utility arm opens and it closes. Why, when I'm driving the droid along by radio control and I drive it up to someone, I'm the puppeteer, remember? So when I meet someone, I say hello. Well, the droid is going to do the same. It's going to open its utility arm and it's going to make a hello sound. A beep sound, and that's its welcome, hello. It might close its utility arm and make another sound. It's got 2 utility arms, so the lower one opens and makes another sound. Well, it's really simple. All I do is put a switch behind them. So as the utility arm opens, it closes the switch. And it opens the switch, and it closes the switch. And all right, it's the same sound that's triggered each time as the utility arm opens and closes, but when I meet people, I don't use different words. I say hello or I say hi. I mean, it's not, they're the same kind of sounds. Why would you change the sounds for a greeting? It's the same sound. Now, you could use multiple switches. So, for example, you could have 2 switches per utility arm, an opening sound and a closing sound. Now, if you've got 2 utility arms, that's 4 sounds straight away on your robot. If you've got a little door that opens, put a switch behind it, makes another sound. If you've got a little periscope that comes up and down, put a switch behind it, makes it another sound. These are £2 switches, £10 board. I mean, it's incredibly cheap a way to do it. And it kind of automates it. When I'm controlling my robots and driving around, I'm not really always triggering the sounds. I'm letting the robot trigger its own sounds because they're mechanical, they're physical. Something touches the switch to mechanically trigger it, which triggers the sound. So that's the first way to trigger a sound, a switch. Keep it simple. What if you don't have any moving parts? What if it was a wheel rotating or a dome rotating on a droid? Let's say I wanted my Dalek to make a sound as soon as it starts to move. Well, it's very difficult to fit a kind of mechanical switch in. I'm sure there's ways of doing it, but it's quite difficult to do. So we need a different kind of switch. And the kind of switch we want to use is an electronic switch. We call them relays. But that's all it is. It's an electronic switch. It does exactly the same thing as this. It's exactly the same. They come in this little box. They look like boxes. And inside these little boxes, there's just a switch, right? But it doesn't require you to touch it like a switch, like an analog switch does, in the same way. What it requires to make it work is voltage going into it. So what we do is we put a voltage into this side of it. And this one's quite easy to see, actually. We've got input and we've got output. Now, we know where the output goes. The output is going to go directly to our soundboard, like that. Because we know that in here is a switch, and in this normal position, the switch is open. When we put voltage into these pins here, it switch closes. So imagine my finger is the voltage. All it does, voltage on, voltage off, voltage on, voltage off. It's that simple. That's what a relay does. It's an electronic switch. So imagine, well, we know we've got voltage going to our motors because that's what makes our Dalek, our droid, our object drive. Well, simply take some of that voltage that goes into the motor, tap off it, plug it into this terminal here, connect that to your soundboard. As soon as this sees voltage, as soon as you power your motors up, voltage goes in there and it triggers a sound. And again, you can use as many of these as you want to trigger as many sounds as you want. In fact, that's a single one. So obviously, that's a single relay. That will trigger one event. Here, you can see there's 4 little boxes, 4 relays. This one has got 16 relays built in, 16 switches, but they're exactly the same thing. It's an electronic version of this, which can trigger a sound. Now, these are slightly different in that, yes, we'll come back to this actually later on because there's another application for that as well. These are quite clever little gadgets. Now, what this one is, this is a 4-way relay and this is a 16-way relay, and they're actually controlled from these things. Now, you've probably seen people walking around with these button boxes and pressing buttons. Basically, think of it as they generate voltage. When you press number 1 on here, it transmits via radio waves. Now, it's not Bluetooth. It's a little bit faster. It's a lot faster than Bluetooth. I can't remember what the frequency is, 433 or 344. But basically, it transmits to this one. You can see there's a little aerial and there's a little antenna there on the unit here. This sits in obviously in your robot, and this is you attach this by a Velcro or something to your transmitter, or you can just walk around with it. When you press number 1 on here, it turns relay number 1 on or off. When you press number 2, it turns relay number 2 on or off. So again, just connect your sound board directly up to the relays, and you've got all these little things down the side you can connect things into. And what we can now do, instead of having the sounds tied to a physical object like a motor rotating or a utility arm opening, we can now switch the sounds at random whenever we want to with that. So that little unit is kind of like the relay and Bluetooth kind of all combined together to control the soundboard. I use this a lot in, well, most of my robots have these systems on, because I can randomly switch sounds when I want to, or music when I want to. But for systems that I want to automate, I simply use switches or I use relays. And it really is that simple. Now, you might be thinking, okay, that's great. I can use my soundboard. It's going to cost me a tenner. I can connect it to my £2 switch and I can get sound. What if I wanted to control all this from my radio control unit? Because I've got this in my hands and I've got lots of buttons on it. What if I wanted to flick a button on my radio control and I wanted to trigger a sound? Well, you can do that. It's easy. What we need is one of these. And this is simply a RC switch. Now, what that means is it's a relay that can connect to your radio. Cost about, I don't know, £10. So they're not cheap, but what they allow you to do is connect this to your radio. So here's my little receiver. I simply connect it to my receiver like that. And there's my switch. And then these two wires are my output, which of course connects to my soundboard like that, each of my triggers. And what this means now is if I connect that to channel 1 on my radio, when I flick my control button to control channel 1, it turns this switch on, which makes my sound. So it's like this, but for the radio. And again, people use these. You can use these to control lots of things, not just sounds. You can turn circuits on and off. There's all sorts of things you can do with radio control switches. So it's similar to this, but it's using this to get the sound inside your radio channel. And this is, like I said, it's an RC switch. Now, you might be thinking, well, hang on a minute. If I want 8 sounds, and these are £10 each, that's £80 just for these little things. That's quite a lot of money. £80, then £10 for that. That's £90. It's all starting to get expensive, isn't it? Well, yes, it is, and no, it isn't. There are lots of ways to solve problems. Now, this is a great little gadget. Now, I think this is a bit, in the modelling world, these are a little bit, I think they're kept a little bit secret in the modelling world. They generally don't cross over much to the robotics world, because I think the robotics world see them as a bit of a waste of time, because really, what is it, first of all? So there's lots of wires hanging around. So all of these are LEDs, different LEDs. And here we have connections that connect to the receiver, channel 1 to channel 3. So 3 channels. And these simply connect directly to my receiver, right? And here's the clever bit. These are connected to my receiver. So if I flip channel 1 switch, it turns on an LED. If I flip channel 2 switch, it turns on an LED. If I flip channel 3 switch, remember these are connected to my receiver, it turns on an LED. So we can do things like connect this to my speed controller. So I can plug that into my receiver. And then I find that's number 1, and I get the other one, the other end, plug that into my speed controller, or my speed controller plugs in there. It's kind of like a loop through. But this is the clever bit. When I move forwards, my headlights come on. When I stop, my brake lights come on. If I do that onto channel 2, and I turn left and right, I've got indicators left and right. So we've got a whole lighting solution here for 10 quid. And they're incredibly useful little gadgets because basically we've got, where is it gone? 3 of those in that. So these are £10 each. This is £10 for 3, all built in. So how does this help me switch sounds on and off? Well, remember back to this. This little relay costs £2. What it costs, that's all they cost. They're very, very cheap. So we know to trigger this relay, because remember our sound card was attached to this side of the relay, this side of the switch. To turn this relay on, we need voltage going in. Well, we also need voltage to light an LED. So it's kind of really simple, isn't it? The next bit, we simply connect that into there. We can even keep the LED if we wanted to. So now, when we flick channel 1, it sends a signal, turns it into a voltage, triggers the relay, which triggers a sound. So, £2, £10, £10. You can see this is all starting to be quite cheap. So £10 for your soundboard, £10 for 3 sounds, and £2 for each switch. It's not exactly going to break the bank when you're building a system here. It's very, very doable. And normally what happens is a lot of these things don't cross over. These kind of stay within the RC world. These stay within the robotics world. They tend not to cross over. But what you can do very, very cheaply is build a system that can be very, very good, but more importantly, can be custom made for what it is that you want it to do. Now, I know people are probably thinking now, well, hang on a minute, why do I need to do all this stuff when I can go out and buy my own solution? There's loads of systems out there that do all of this for me. Agreed, there are. I'm not going to actually name any of them, actually, because if you want to know about them, those systems, then message me and I'll tell you. But there are systems that you can buy off the shelf that combine all these things together into a single board. You simply plug your SD card, let's use this as an example, plug your SD card in, wire it up, it gives you all your sounds. You don't need to be messing around with RC switches or buying things like this, or relays or switches. You don't need to do any of that, it does it all for you. But it does it at a price, at a cost. And it's significantly more than doing something like this. An example, as I said, £10 for a soundboard. This unit here, this is a 16 channel board here, £25. So £25, that's £35 for a complete solution, a complete sound solution. Random sounds up to 16 sounds, all controlled on a board. All right, yes, you need power supplies to plug into this stuff, but you'll have those anyway. And you will need an amplifier, but you'll need that even for the more expensive solutions that you can go and buy. And there are, off the top of my head now, I can think of 10 that you could go and buy that off the shelf that will do all of this. But as I said, they do it at a price. Now, don't get me wrong, these systems are outstandingly good at what they do. They give you things like interface with your radio. They give you touchscreen options. There's an amazing German piece of software that runs on the Ethos system to control radio control vehicles. It's stunning. It's stunningly good. But all of them come at a price. You choose if you want to buy it, if you want to pay it, great. I'm just showing you an alternative here that you can do with little bits and pieces and keep it really, really simple. And at the basic level, and sometimes, you know, as I said before, keeping it simple sometimes works the best. At the basic level, all you need is your soundboard. Let's power it up. And a switch. So I'm not sure I'm going to be able to hold all this together. Let me try and see if I can. And there's my... That switch is designed to close to make the connection. But basically there, I'm just touching 2 wires together. All you've got to do is connect a switch. Put it behind a robot arm or a physical moving thing. And for the cost of a £2 switch, and a £10 board, there's your sound solution. Anyway, I hope that helped. There's a lot of me going on about things, I know, but find a way to solve the problem. It's quite fun, it's quite exciting looking at what other things are doing. Like this was quite exciting when I discovered about the voltage switching and then how you can switch it to relays. Of course, for those of you that are thinking, well, you know, it's all too complicated, you can take it back to basics. Just think it through. Think about what you want to do. For those of you thinking, well, hang on a minute, this could be really exciting. Yes, it can, because as soon as we get a sound onto an RC switch, so as soon as we bring the sound trigger into the RC realm, we now have controllability within the radio. Now, if you're using operating systems like Ethos, the possibilities with logic switches for triggering sounds become incredible, because instead of triggering just sounds via switches, we could trigger sounds on any point in an RC curve. So for example, we could have 8 sounds that could trigger at different times. So let's say on our board we had an engine startup sound, we had an idling sound, we had a revving sound, and we had a stop sound for a model. Let's say a radio control tank, for example, which you know I'm building. We simply put those sounds through logic switches to a different point. We say at 10% trigger this sound, at 20% trigger this sound, at 50% trigger this sound of the position of the throttle, which we can do in Ethos. Then all of a sudden, we've got a sound that's variable with an engine speed. That starts to get exciting when you're doing modelling like that. If you were doing, and I've already done this on Tiffany with the guns spinning up on Tiffany. We have a minigun startup sound, and then we've got the guns spinning up and the guns spinning down and ejecting bullets. All of that is done using the Ethos, using the logic scripts in Ethos with a £10 soundboard. Hope some of that helps.